Okay, so this is going to be basically day 2 of solving polynomials. And so in day 1, we did basic solving polynomials where you find your solution, one of your solutions through the graphing calculator, and then you use synthetic division to get it to a quadratic, to where you can use the quadratic formula to solve. And that was a basic version that in most cases, that's what you'll see. But now in today's lesson, we're going to look at some of those variants as to, what other ways can we see these type of problems. So once again, we're going to need our graphing calculator, obviously. So I have my graphing calculator here. And so we're going to start off with doing a problem that's similar to ones that we've done before, and that is a simple kind of x to the third type of polynomial. And so at first it looks like a normal polynomial, and so you look at it and go, okay, I'm going to put this in my graphing calculator and then solve it. So I'm going to go ahead and put this into my graphing calculator so I can see if I can find one of my solutions. So there's the formula in the graphing calculator, and so I go to my table of values to look for my answer. In some cases, you're going to have to move up and down just to maybe find it, but there we go. We can find it there, the 0, where y is 0, x is -5. So I do get a solution of -5 that I can use in synthetic division. So nothing new here. I'm just going to run this through synthetic division, and then we can go from there. So I have, which number comes down, 1 times -5, -5, -3, -5 is -8, -8 times -5 is 40, -15 plus 40 is 25, 25 times -5 is -125. And so I do get that 0 that I want there at the end. Remember, the whole purpose of doing this is so we can get it into a type of equation that we can actually solve. So now that it's in a quadratic now, because it was in a cubic, so when you do synthetic division, it reduces down a degree into a quadratic. So here's our quadratic equation. And so then we can use the quadratic formula for this. So I'm just going to move this over to the side here, and I'm going to then use the quadratic formula to find my other two solutions. I have one of my solutions there, -5. I need 2 more because that's what the exponent tells me. And so the other 2 are going to be found using quadratic formula. So quadratic formula is x equals -b plus or minus the square root of b squared, which is 64, minus 4 times a times c, which is 25, all over 2 times a, which is 2. We do our discriminant first. 64 minus 4 times 1 times 25. We're going to do that. And so what you're going to see here, and what makes this a variant and what makes this a little bit different than what we did last class, is that when you do your discriminant, you actually get a negative radical. Now, this shouldn't be a shock in a way that we don't know what we're doing here. We have seen and dealt with quadratics that have negatives in the radicals and how to deal with it. So if you remember back to when we did quadratics, if you place an I in front of the radical, it does make the radical a positive 36. And so from there, I can solve. And square root of 36 is 6, so I get 8 plus or minus 6i over 2. And then that'll reduce, since everything can be divided by 2, to 4 plus or minus 3i. And it's over 1, but we don't need to divide by 1, so that would be our answer. And so there is my other 2 solutions. The plus or minus counts as 2 solutions, so this is technically 2 solutions here, with our third one being -5, and that is sufficient for the number of solutions that I should get. So that's the one type of variant that you'll see. The first part is not really different. It's when you get to the end here and you get a negative in the radical, and so you will have some of the solutions. You may have solutions that are real as well as solutions that are imaginary. The other type of variant is when we get to work through polynomials that are greater than an exponent of 3. So this is an exponent of 4, a polynomial with an exponent of 4. And so that changes things a little bit, because if you remember, when you use synthetic division, that's going to reduce it by a degree. So our answer will be an x to the third, and we still don't have a way of solving the x to the third. So let's look at this. We're gonna plug in our equation into our y equals and see what this looks like. So x to the fourth, and then minus 3x to the third, and then plus 6x. Oh, not times. Plus 6x and squared plus 2x and minus 60. So we have everything in there, and again, we're going to go to our table of values and see what solutions it gives me. And so again, you might need to move around a little bit, but one thing you'll notice here is that this particular problem actually gives you 2 solutions. It gives you a solution of -2 and +3. So I have 2 of my 4, I should have 4 solutions, 2 of my 4 solutions right there. So when you go to run it through synthetic division, you actually get to choose on which solution that you want to use. So I don't really need the calculator anymore. So I'm going to use 3. It's just easier when you work with positive numbers. And then I'm going to put all the coefficients and constant in here. First number down, 1 times 3 is 3, -3 and 3 is 0, 0 times 3 is 0, 6 and 0 is 6, 6 times 3 is 18, 2 and 18 is 20, 20 times 3 is 60, which when you add those, you do get that 0, and that's what you should get. We should get 0 at the end. And so when we write our answer, it reduces by a degree. I don't have an x squared, 0x squared, so I don't have to write that. You can just skip that one and go right to the x and then a constant. So here's where our problem is. So we used a solution and ran it through synthetic division, and we ended up with a cubic. And so again, there's not really any way to solve a cubic that's not factorable. So you might be able to guess what needs to happen next, but what happens now is there's a reason why it gives us 2 solutions, and the reason is because we need that other solution. And so most kids get they figure out what needs to be done here, but basically you need to run synthetic division again using the other solution. So instead of using 3, I'm going to use -2. And I'm not going to plug it in to the original. That wouldn't make any sense to plug it into the original, because I would just end up with a cubic again, and that doesn't help me. But what we can do is we can actually use the reduced function that we got when we ran it through synthetic division the first time. We can use this equation in synthetic division. So a 1 for the x to the third, a 0 for the x squared, a 6 for the x, and a 20 for my constant. And so when we run this through synthetic division with our new equation, here's another one of our solutions, you'll see that we can reduce it down to a quadratic. And I'll just do this real quick, and then we get a 0 at the end. And so yeah, and so now I got it down to a quadratic, x squared minus 2x plus 10. From there, you would just run it through quadratic formula again. So I'm not going to do quadratic formula again. I think you've seen that enough times. But you will need to run this through quadratic formula again to get your other 2 solutions to make a total of 4. And I believe in this one you do get imaginary solutions as well, same as what you got in number 2, or similar to what you got in number 2. So all of these, all of these are the same. So with number 3, you would do the same thing. Just be careful; it's missing a few terms there, but you can go ahead and try to do that one as well. This one, I believe you end up with -7 and 7, and then when you run them through synthetic division twice, you end up with a quadratic that's x squared plus 1, and when you use the quadratic formula, you end up getting plus or minus I as your other two solutions. So if you want to try it out and see if you do get these answers, I want to just give you those answers. So if you wanted to try it and see what you got, then you can do so. The last thing that we're doing in this particular lesson is now going backwards with polynomials. So the last several days, we have been given a polynomial equation and asked to solve it and find the solutions. Well, in this particular part of the lesson, they're going to give us the solutions to the polynomial, but we have to write the polynomial. We don't know the polynomial. We just know the solution. So in other words, we're going to go backwards, go from solutions to problem instead of a problem to solutions. So the way that we do this is in order to go backwards, you kind of have to remember how you go forwards. So what I did in class was I kind of just had kids remember when you were factoring a question like something like this. So if I wanted to factor a question like this, so I do like my a times my c, that's -28. B is -3. What multiplies to be -28 and adds to be -3. And so when you factor it, you're like, oh, okay, I think that's -7 and 4. -7 and 4 multiply -28. -7 plus 4 is -3. So when you do your dead cartoon eyes, you get x minus 7 and x plus 4. When you solve, because b equals 0, we have to solve. We have to set each one of these equal to 0. And when you add the 7, you get x equals 7. And when you subtract the 4, you get x equals -4. And so you quickly realize that the answers are simply just the opposite signs of whatever you got in your factoring. So when I got a factoring of x minus 7, I know that the answer will just be 7. And I got x plus 4, the answer will just be -4. So if we know that, then it makes it easier to understand how we can work ourselves backwards. So in this, we're going from a function to solutions. Now we want solutions, and we want to end up with a function. So if we could go from solutions to factored form by simply just flipping the signs, so a solution of 7 is x minus 7, and a solution of -4 is x plus 4, we can get it back into factored form. So over here, we're going to do that. We're going to take a solution of -4 and just put it in factored form by saying that that's x plus 4. A solution of 1 when in factored form would be x minus 1. A solution of 7 would be x minus 7 in factored form. And you probably can guess what you need to do now. In order to get this into a polynomial, yes, you're going to have to multiply all of these. Okay. And remember, you can only do 2 at a time, so you kind of separate the x minus 7 and do the first 2. When you do multiply that all out, you end up with x squared plus 3x minus 4. And then when you bring this down and do x minus 7, then you need to multiply all of these again. And then what you end up with is x to the third, and it looks like -4x squared, and then you have -21, -25x, and then +28. So when you multiply those all out and then combine like terms, you end up with a polynomial function. So what this is saying is that this polynomial, if you were to solve it, you would get the solutions -4, 1, and 7. So again, to recap, you just take your solutions, put them in factored form by just flipping the signs, multiply everything out, combine like terms, and then you'll end up with a function. The same thing can be done with a graph too. So when we look at a graph, remember your solutions are where your graph crosses the x-axis, or your x-intercepts. So here we have an x-intercept of -1, so in factored form, that'd be x plus 1. An x-intercept of 2 would be x minus 2 in factored form. And a solution of 3 in factored form would be x minus 3. And same thing goes, you'll just multiply them all out. I want you just to take note that we don't use this one. Remember, your solutions are x-intercepts. And what this is up here is a y-intercept. So we don't use that one. What you'll find out is when you multiply everything out, that c value at the end will be 6, which is your y-intercept. But that's how you do these types of problems. So thanks for listening.